So friends, today we are going to learn about the measurement of length. The measurement of length is done by using meter scale. So if you want to measure the length of this object, so this can be done easily with the help of a meter scale. Here you can see we have got a meter scale, friends. So one end of the object is coinciding with 0 of the meter scale, and the second end of the object is coinciding with this reading on the meter scale. We can simply compare the length over the meter scale and we can get the measurement of the length of the object. So here if you see, friends, the length of this object is around 18 mm. This reading indicates 18 mm, that is 1.8 centimeter. You can see here the smallest measurement that can be done with the help of meter scale is 0.1 centimeter or 1 mm. So here the one division on the meter scale equals 1 mm. So if you look at this end of the object, it is slightly more than the 18 mm, we can say, but the measuring scale cannot measure this much length because the least count of the measuring scale is 1 mm. So it can only measure up to this much reading, that is 18 mm. But the actual length of the object is slightly more than the 18 mm, as you can see from this particular picture. So the problem is the measuring scale cannot measure any dimension which is less than 1 mm. So you can see here this much variation cannot be measured with the help of measuring scale because the least count of the measuring scale is 1 mm. Now what we can do, if you want to measure any distance or any length smaller than 1 mm, then we have to go for another instrument which can have least count lesser than 1 mm. So let's learn about the another measuring instrument called as Vernier Caliper. So if you look at this picture, so this shows the Vernier Caliper. So Vernier Caliper is used for measurement of length, and the least count, the smallest measurement the Vernier Caliper can do will be lesser than 1 mm. Sometimes it is 0.1 mm depending on the scale. So I will explain you here how the measurement of the length is done with the help of Vernier Caliper. So Vernier Caliper basically follows the principle of differential measurement. If you look at this Vernier Caliper, friends, it has got two scales. One is over here, the larger scale you can see here. This is called as, friends, main scale, and the smaller scale, this one is called as vernier scale. The vernier scale, what you can see here, is movable. This particular scale is going to slide over the main scale. That we can see as we go for the measurement. Just remember, vernier scale is going to slide over the main scale during the measurement. So what happens, we can put an object in between these jaws. These are called as jaws, friends. These are jaws of vernier caliper. So when you put an object in between these two jaws, then reading will be obtained over the main scale and vernier scale. The method what we are going to use is called as differential measurement. So two scales here, that is main scale and vernier scales, having divisions of slightly different size are used. So here if you look at here, friends, I can tell you this is the main scale over here. So main scale has got the divisions like 0 mm, 1 mm, 2 mm, like that. So if you look at this, the one division equal to 1 mm. So the smallest division over here on the main scale is 1 mm. And if I show you the vernier scale, this is the vernier scale, friends. The length of one division on vernier scale is slightly lower than the length of one division on the main scale. So you can see that one division on main scale is 1 mm. From here to here is 1 mm, friends. This is 1 mm, while this reading is 0.9 mm. So there is a difference. If I say for one main scale division minus one vernier scale division, okay, this value is 1 minus 0.9, that is 0.1 mm. So the difference between the size of division on main scale and size of division on vernier scale is 0.1 mm. So this difference will be used for the measurement of length. I will explain you as we go along how this difference is going to be useful during the measurement, because we are going to follow differential measurement. So just for understanding point of view, just remember the two scales, that is main scale and vernier scale, having division of slightly different size. Okay, so as you can see here, now the difference between the divisions on two scales will be given a smallest accurate measurement. So this difference, whatever we are getting, that is 0.1 mm, will give us the smallest accurate measurement you can do with the help of what? Vernier caliper. So remember, the measuring scale we used earlier was having least count as 1 mm, right? But here the least count is going to be the difference of divisions on main scale and vernier scale, and that is 0.1 mm. So this 0.1 mm is going to be the least count. So you can see here, with the help of two scales and doing differential measurement, we are able to reduce the least count to 0.1 mm. Okay, so when we use single scale, it was 1 mm, but here it is 0.1 mm, right? So least count has improved significantly. So that is what, whenever you use a vernier caliper, two scales are used and their differences of division values will give us the smallest accurate measurement that can be done with the help of that instrument. So this is also known as the least count LC. So that is what I have written here, friends. The smallest measurement, that is least count for a vernier caliper, is 1 main scale division minus 1 vernier scale division. That is size of main scale division minus size of vernier scale division will give us the least count. Okay, so I'm going to explain you the procedure of differential measurement. Let's say that we are inserting some object between these two jaws of vernier caliper. So when you insert some object here, this vernier scale, which is sliding over the main scale, is going to move towards right, something like this, friends. You can see here the vernier scale 0 has shifted towards right. So it means we have inserted here an object of this much thickness or this much size, we can say. Okay, it means the object which is there in between these two jaws has this much size. Now I cannot measure this size exactly, right, because it does not show anything. Say that this distance is x, for instance. So I want to measure the value of x, friends, right? So here we know that this is going to be 1 mm, and this much from here to here, if you see, the vernier scale is, this is 0.9 mm, friends. So if I simply compare both, I can say the value of x is going to be the difference of one division of this and one division of this. That is difference of one division of main scale and one division of vernier scale. That is 1 mm minus 0.9 mm. So I can easily conclude from here that x value is going to be 0.1 mm. So the value of x is going to be 0.1 mm. So this is how the differential measurement works. Okay, now let me insert another object over here so that size will be increased, and then also we'll try to understand. Now see, this is, so now this has shifted towards right further, and now I can see here the gap has widened here. Okay, so now it is coinciding with second division. You can see the second division of vernier is coinciding perfectly with the second division of main scale. That is very simple. So if you want to find this much gap, now if this is x, friends, so I can easily conclude from here x equal to what, friends? Now second division is coinciding, so from here to here is 2 mm, and from here to here is 1.8 mm, friends. So difference is what? 2 mm minus 1.8 mm, that is 0.2 mm. So this is very simple. So this is going to be 0.2 mm. Okay, so you can see here the differential measurement is working over here, right? Even though I don't have any marking on this, but I can measure this gap by seeing which division is perfectly coinciding. When the second division is coinciding, so this value is going to be 0.2. So 0.2 is nothing but, I can say, so already we know, friends, what is least count. So least count is nothing but 1 main scale division minus 1 vernier scale division, right? So the least count is 0.1. Already we have done it. This is nothing but 0.1 mm. So this gap will be 2 times least count. Simple it is. X is going to be 2 times least count, straightforward, right? Let's take another example. I'm going to increase the gap between the jaws. So let's see what happens here. So here I can see that third division is coinciding. So this gap will be simple. Straight away I can say when it is third is coinciding, third division is coinciding, friends. You can see here, friends, third division is coinciding. It means 3 times least count. Okay, and you can see from here also, from here to here value is 3 mm, while from here to here value is 2.7 mm. So difference is going to be how much? 0.3 mm, right? So 3 into 0.1 mm, straightforward. So this is nothing but least count, friends, right? So we simply multiply by the least count if I want to get this gap. If it is third division coinciding, 3 times least count. So similarly, friends, if the fourth division coincides, the gap can be written as simply 4 times 0.1 mm. So this gap, that is 0 of main scale and 0 of vernier scale, you can easily get it, right? Now I'll do another exercise also to make understanding more clear. So here, so if the gap is widened, for instance, if you put larger size of object between jaws, and you see that the 0 of vernier is coinciding with 1 mm of main scale. You can see here 0 of vernier is coinciding with 1 mm of main scale. So it is exactly the values, from value between 0 and 0 is going to be straight away how much it is? 1 mm. There is no confusion, right? But suppose it goes further over here. Now if it goes further here, friends, so this reading is known to us from here to here. This particular reading from here to here is called as main scale reading, because it is reading on the main scale. It is called as main scale reading, right? But further this much gap is not known to us, x, right? Now if you look at here, friends, the first division on the vernier scale is coinciding here properly, right? So this is going to be 1 times least count, because I have told you whatever is coinciding, that is going to be this value, right? The first division is coinciding, so here the actual reading will be, or length will be, friends, I can say the main scale reading plus whatever division is coinciding. So here division is 1, so 1 division times least count, like that value will come. If you look at here, the main scale reading is 1 mm plus 1 into 0.1 mm, and if you solve it, you will get 1.1 mm straightforward. So this is how the measurement is done. Similarly, if I increase the size of object, so now you can see here the second division is coinciding. So the main scale reading is, again, you can see here, this is going to be 1 mm plus I want this much gap. So this much gap is nothing but 2 times 0.1. So main scale reading, again, the main scale reading indicates this one, and that is again 0. That is 1. So main scale reading is 1 mm, while this gap is second division is coinciding, so 2 into least count, that is 0.1, like that. So you'll get 1.2 value will come. So this is 1.2 mm, like that. Okay. So always you have to see, again here the main scale reading is going to be same, 0 to 1, that is 1 mm, and this gap we are looking for, this gap is nothing but, because third division of the Vernier caliper is coinciding perfectly, so 3 times least count will come. Okay, so this same way you can continue and you can find out the value of any length with the help of Vernier caliper. So this is called as differential measurement. The difference between main scale division and the Vernier scale division plays the role of measurement in case of Vernier caliper. Okay, so we'll do some simple examples, and from that examples we'll try to understand how to do the exact measurement. Okay, so here I have drawn the Vernier caliper in the larger scale so that we can see the things. This is basically Vernier scale and this is called as main scale. If you look at this carefully, you can understand that, friends, this one is the main scale, you can see the upper scale, the larger scale, and the below over here is called as the Vernier scale, right? So whenever you start the measurement, you have to first find out the least count. So what is the least count? That is very important term. So least count is basically the difference between the size of one division on main scale and the size of one division on the Vernier scale, right? This is how we do it. Okay, now if you look at here, the size of one division on main scale is going to be, because from here to here is going to be 10 mm or 1 centimeter, right? And from here to here, if you come up to here, friends, Vernier scale is up to here, friends, so this is nothing but 9 mm. Okay, so one division on main scale is nothing but 1 mm. You can see here this size is nothing but 1 mm, while from here to here, friends, we have got 10 divisions of Vernier scale, but the length of 10 division is nothing but 9 mm. You can see here 1, 2, 3, 4, 5, 6, 7, 8 and 9 mm. So 9 mm for 10 divisions. So for one division it is going to be, I can say for one division it is going to be 9, overall distance is 9 from here to here, divided by 10, and that is going to be 0.9 mm. So the length of one division on the Vernier scale is 0.9 mm, and length of one division on main scale is 1 mm. The upper one is called as main scale, friends. This is main scale and this is called as Vernier scale. Okay, so least count is nothing but 1 main scale division minus 1 Vernier scale division, and that turns out to be, friends, 1 mm minus 0.9 mm, and that simplifies to 0.1 mm. That's the simple way of finding out least count. There is one more way of finding out the least count, and that is called as, one more way is there for least count, that also we can do, and that is called as smallest division on main scale. Smallest division on main scale, and that you divide total number of divisions on Vernier scale. That is also a method, same method, total divisions on Vernier scale. So here if you see, the smallest division on main scale is, friends, the smallest division of main scale is 1 mm. So it is 1 mm divided by number of divisions on Vernier scale is 10. By this rule also you get 0.1 mm as least count. Both are same thing, only the perspective changes, right? Only the perspective changes, because the smallest division is 1 over here and the overall number of division of Vernier scale is 10, so 1 upon 10 is going to be 0.1 mm. So we can easily calculate the least count of Vernier caliper with the help of these two methods. Okay, now I'm going to proceed further and see how we can do the measurement of an object, measurement of the length of the given object. So I'm going to explain you the measurement procedure with the help of Vernier caliper. So an object is given to us, let's say, and we are interested to find the size of this object. That means we want to find the length of this object, friends. So we are interested to find this particular length. Let's say it is L from here to here object, right? So this length will be, if I want to calculate this length, first of all, so we first of all see where 0 of the vernier scale is coinciding with the main scale, let's say. So this is the 0 of vernier scale and it is coinciding somewhere here. So let me first mark it here. So this is, it is coinciding, friends. So definitely the length is going to be from 0 to this value, right? So this value already we can know here. You can see here this much value you can easily calculate from the direct measurement. That is, this is, let's say this is 5 mm and this is 10 mm, 11 mm, 12 mm. So 12 mm is fixed. Okay. So this is called as the main scale reading. We are sure about this reading, that is main scale reading. So this is the reading where 0 is closer to that value, right? So 0 has to be closer to it, means it should be more than that value, right? So this is called as main scale reading. Whenever you do the measurement, this has to be, this reading is known as main scale reading, straightforward, right? So the main scale reading is this particular point. So 0 is slightly more than this. Okay, so we will take this as main scale reading. So this is going to be 12 mm, we can say. So main scale reading is, friends, 12 mm. This is called as main scale reading. Main scale reading is what? It is a reading on the main scale at which 0 is coinciding or 0 is slightly more than that. Okay, should not be less than that. To 0 on the vernier scale should be more than that. Okay, so this is the main scale reading. So first of all, if you want to do any measurement, you first pick up the value of main scale reading. So 0 is somewhere here. So this is going to be main scale reading, friends. Okay, this value is not known to us, so that we have to calculate. So main scale reading we got 12 mm. Now we will see, to find this value, friends, to find this value we will check which division of vernier scale is coinciding perfectly with the main scale division. So let's say this is coinciding. No, first is not coinciding, second is not coinciding, third also not coinciding, fourth, fifth. Now fifth is coming closer, friend. Now sixth is coinciding. So this is called as vernier scale division, the division which is coinciding properly, called as vernier scale division, right? So this is sixth division is coinciding, friends. So I'll write down this sixth division, that is vernier scale division, VSD. Now we have already discussed each division, one division difference indicates one least count. So sixth one is coinciding, means this is 6 I have to multiply by the least count. Least count for this is 0.1, just we did it, friends. The least count is what? 0.1 mm for this vernier caliper. 6 into 0.1, so this calculation is called as VSD times least count. So any reading you want to find, you have to get the main scale reading, then vernier scale division. So vernier scale division is a division where it is coinciding perfectly with the main scale division, right? See, you can see here 0, 1, 2, 3, 4, 5. 5 is also not coinciding, but 6 is perfectly coinciding. After that 7 is not coinciding, friend. So whatever is perfectly coinciding, base coinciding, that we have to take that division. 6 is coinciding and that you have to multiply by least count. And least count already we have done it. The previous slide I have told you how to find least count, right? The same vernier caliper I have used here. So the reading I am going to get, this reading I am going to get, friend, is very interesting. It is going to be 12 mm. This also will be in mm, friends. 6 into 0.1 will be 0.6 mm. Overall reading is going to be 12.6. So now you can understand this much variation, which is from this reading to this reading, this is around 0.6 mm. This we cannot measure with the help of normal scale, but with the help of vernier scale I can easily measure this gap. So from here to here is 12 mm, there is no doubt about it, and from this to this, right, this reading is how much? 0.6 mm. Okay, so if you understand the procedure, so how we got 0.6, then there is no difficulty in that. Only this much portion is extra from the measurement. So if you look at here, so friends, here this calculation, that is 6 into 0.1 mm, this much is the extra from normal measuring scale. So measuring scale will do this 12 mm. Okay, if I use any measuring scale, this 12 mm it will measure, but this much gap will be only maintained, will be only determined with the help of vernier caliper or some other instrument which are more precise. Okay, so I hope it is clear to you. So I think the procedure has to be very clear. First you find out the main scale reading. So main scale reading is the reading on the main scale which is closer to the 0 on the vernier scale, right? So this value is called as main scale reading, and then we see which division on vernier scale is coinciding perfectly with the main scale, and that division is 6. That we multiply by 0.1, that is least count. So 12 mm plus 0.6 mm, so it is 12.6 mm, friends. Okay, so let's solve some examples of calculation of length by using vernier caliper. So here we have to find the length of this object with the help of vernier caliper. So let's do it, friends. So this is the length I am going to find. So this length, so here if you see, I want to find the length of the object. So this is going to be the length of the object, friends, and here we have put the object in between the jaws of Vernier caliper. This is the object. So this is the object whose length we are interested to find. Okay, so length is L. So the first reading what we do is we do the main scale reading. Like 0 of Vernier scale is coinciding to certain value of main scale. So main scale here we got 1 friends. So 1 means it is 1 centimeter. This is all in centimeters friends. Remember this is in centimeters. This is in centimeter, and this division is 1 in mm friends. So it is 1 mm, 2 mm, 3 mm like that. So here it is 10 mm, 11 mm, 12 mm and 13 mm. So you can see the main scale is giving us the reading as 13 mm. So it means the length of the object is close to 13 mm, but slightly it is more than 13 mm, right? So 13 mm is fine. So that is called as main scale reading. So I'll write down length will be straightforward main scale reading plus. Now we would like to find this extra value which is there, right? This extra value will be given by which division is coinciding on the Vernier scale. So let's see which division is coinciding on Vernier scale. So 4, 5, 6, 7. If I look at here, again here the 6th is coinciding perfectly almost. Okay, 7th is also very close. So you can take either 6 or 7. Let me say 6 one is proper. So I can say the 6th division on Vernier scale. This one is coinciding perfectly. That is called as Vernier scale division. And that Vernier scale division will multiply by least count. So least count procedure already you know. So least count is very simple. Smallest division on main scale. Smallest division on main scale divide by total number of division on Vernier scale. Total divisions on Vernier scale. This is a simple way of doing it. Now if you look at here friends, the smallest division on main scale is this much division, this value. So the smallest division on main scale, as you have seen friend, it is 1 mm, and number of division of Vernier scale is 10. So 1 over 10, so least count is going to be 0.1 mm. So we have taken main scale reading here. The main scale reading is friends, we've got 13 mm. Vernier scale division we got 6, and least count is you got 0.1 mm friends. If you substitute the values, it is going to be 13 plus 0.6, and that is going to be 13.6 mm. The length of the object we are getting 13.6 mm straightforward. It means up to here it is 13 mm, and from here to here this much gap is 0.6 mm. This is basically, this gap is what? This gap is 0.6 mm. Okay, so 13 plus 0.6 is 13.6 mm. This way we can easily measure the size of an object. Now let's take another example. So friends, this is example number 2. Again we have to measure the size of the object. So here we got the object friends, and its length L we require to measure. Before starting, let us calculate the least count. That is smallest division on main scale. The equation is very simple for least count. The smallest division on main scale, number of division on Vernier scale. Same procedure I'm going to follow here. So if I do normal calculation friend, you see here the smallest division is this. This value is 1 mm. And this is the Vernier scale friends. So division on Vernier scale are 10 divisions, right? So we get 1 mm over 10, and that value will be 0.1 mm. Mind it friends, you can have different least counts. Okay, so whatever Vernier caliper is given to you, you have to find the least count of that particular Vernier caliper. So this least count is not a universal phenomena. It is not going to be same for all Vernier caliper, right? More precise Vernier caliper will have smaller least count. That is possible. Now measurement length we are doing. So we do main scale reading. So we get the main scale reading, then we see Vernier scale division, that multiply by least count. These things are there in normal calculation. Okay, so for main scale reading, we have to check where 0 is coinciding. So if you see here friends, 0 of Vernier scale is coinciding at this line, we can say, right? So this reading on the main scale will be called as main scale reading. This one is called as main scale reading. So the main scale reading over here is, this is 15 and 1, 16. So 16 mm. This is going to be friends 16 mm. Now this much gap we don't know. This much gap, for getting this much gap friends, so we have to see which Vernier scale division is coinciding perfectly here. So if you see here, first division, second division, third not coinciding, fourth one is coinciding perfectly. Okay, so your Vernier scale division is going to be 4 friends. This is the Vernier scale division which is coinciding perfectly with the main scale. This is Vernier scale division, VSD, right? So let's substitute the values and see what we get out of it. So main scale reading is 16 mm. I'll write down as it is 16 mm plus Vernier scale division is 4 and least count is 0.1. This is going to be 0.1 mm friends. This is going to be 16 plus 0.4 mm, and if I do it properly, the length of the object is going to be 16.4 mm. This way you can easily use a Vernier caliper, find the length of an object. So I think you have understood the procedure to find the length of object by using Vernier caliper.